This is the Unit 8 Light and Optics Diffraction problem. Background information. Constructive. Both waves of light travel the same distance they arrive at the screen in phase and interfere. Destructive is if the distance traveled by the light differs by 1/2 the wavelength and the two waves interfere. Background information continued. Diffraction is the bending of light around a barrier. Variables. D equals distance between the slits and is measured in meters. M equals the order number of the fringe and it has no units. Theta is the angle from the center max and is measured in degrees. Lambda is the wavelength and is measured in meters. That's awesome. The formulas on the units. For constructive is D times sine times theta equals plus or minus M times lambda. Example problem. Light falls on a double slit separation of 9.05 times 10 to the negative 7th meters times the third bright fringe. Is seen at an angle of 30 degrees relative to the central maximum. Find the wavelength of the light. This just shows you the diagram in the picture. Given the D is equal to 9.05 times 10 to the negative 7th meters, theta equals 30 degrees, M is 3, and lambda is what we have to find. The applicable equation to solve is D sine theta equals plus or minus M times theta. When you plug in the numbers, you get 9.05 times 10 to the negative 7th times sine times 30 degrees equals 3 lambda. When you show the algebra, you'll get 9.05 times 10 to the negative 7th times sine 30 over 3. And when you solve it, lambda equals 1.51 times 10 to the negative 7th meters. Okay.